This is an explanation of the distance equals rate times time simulation worksheet, or D equals RT. So if you weren't in class, what we did for this assignment is we set up we set up 5 of our tables in class, the little rectangular tables, and put them in a row, all touching each other. And then we had people with a little toy skateboard. It's a little tiny skateboard that people, quote, drove with their hands across the table. And they would start here, and we called this 0 meters. And then we pretended that each time a new table started was 10 meters. So this was 10 meters, 20, 30, 40, and 50 meters. And then I gave instructions to each of these skateboard riders as they wheeled their skateboards across the across the tables. I gave them different instructions. And so if you're doing this at home, you can just use this already filled in sheet, which has all the time. So we have Layla, and Layla's instructions were to go at a constant speed. Khalil was supposed to start slow and then speed up. Ziggy started fast and slowed down, etc. So these numbers are the times, how many seconds had gone by when they reached these marks. So for example, Layla started, and I had students at each of these spots here with their timers on their phones, timing how long it took to get from the start to their spot. So Layla passed the 10-meter mark at 1.8 seconds, the 20-meter mark at 3.6 seconds, the 30-meter, 5.2, and then she was all the way at the end here at the 50-meter mark, 8.7 seconds. And then, of course, we had different students reaching those marks at different points depending on what they were doing there with their skateboard ride. To get their average speed, we took, so speed in this case speed is always distance per time, distance over time. Like you might hear miles per hour is a typical speed we use in the United States. For this particular lab, the units were meters per second, because the distance was measured in meters and the time we were measuring in seconds. So to get the average speed, the speed of the whole ride at the end of the 50 meters, we took the full distance, which was 50 meters for most of the riders. A couple people, I had them do something different. And then we divided by the full time. So for Layla's situation, it was 8.7 seconds. We used a calculator, and that turns out is 5.7 meters per second. So that was Layla's average speed. We have one unusual one here. Dawson, I instructed him to turn around in the middle of his ride. We said that he hit a wall and he couldn't go over the wall. And so what the numbers here at the top of his, the top here are the times that he hit each meter mark, but then he never got past the 30-meter mark. So if we look at our thing here, there was basically we put a little wall here between the 30 and 40-meter mark, and when he got to that, he got stuck, and he had to turn around and go back to the beginning. So his times reflect that. It took him 2 seconds to get to the 10-meter mark, 4 seconds to get to the 20, 5.4 to get to the 30-meter mark, but then he got stuck. In between the 30 and 40, he had to turn around. He went past the 30-meter mark again at 7.5 seconds, and then came back to the beginning, the 0-meter mark, at 18.2 seconds. Rowan was backwards. So Rowan started time 0, she was at the 50-meter mark. And then after 13.1 seconds, she was back at the 0 meter mark. So her particular, let's see, I'm going to erase this here. Her particular run had her starting at the end and going this direction. Tara crashed in the middle, and here was her crash right here between the 20 and 30 meters. She had a crash, so that slowed her down, but then she started up again and finished. So down here, you can write the people's names again, write their starting coordinates and their ending coordinates, and we'll look at this in a minute. Slope of the line drawn between the start and end coordinates. So let's go to the graph. This page is you'll do on your own. It's just some practice problems. And here's the graph. So on here, we've graphed Layla's. And so we're doing ordered pairs. So we know at 1.8 seconds here, she hit the 10 meter mark. So that's this point. It looks like at, let's go back up to her time. So here, 3.6 seconds, she hit the 20 meter mark. So 3.6, so we go up to the 20 meter mark. That's this point. And then I think it was 5.2, she hit the 30 meter mark. And so we gave her a blue color. And we took a ruler and we connected her dots. But then what we did, and we did this for all of the students, we took her very end time when she reached the 50 meter mark at 8.7 seconds, and we took a ruler and we drew a straight line between her starting point, her starting coordinates, which were 0 seconds and 0 meters, and her ending coordinates, which were 8.7 seconds and 50 meters. So you're going to do that for each student. Dawson's was kind of unusual, because it's kind of going along like other students here, but then at the 30 meter mark, this is where he hit the wall and he didn't make any progress. So time kept going, but Dawson did not get past that. He actually didn't make any progress right there in between 6 and about 7 something seconds. So he had to turn around, and then we see him with a downward sloping line. So time is still moving in the positive direction, but he had to turn around and go back to the beginning. So he's going in the negative direction for distance. Okay. So when you connect Dawson's line, that'll be a little unusual. I guess you could do one line that connects his start end until he got to the 30 meters, and then we can do another line. That is not very straight, so you should use a ruler connecting those. Okay, so you're going to do that for each person's, and you're going to use you're going to use the colors that I've indicated here for each person. Then you're going to figure out the slope of the line drawn between the start and end coordinates. So those are these straight lines we drew in between the start and the end coordinates. So this line right here. All right. And remember that slope of a line, the formula is y2 minus y1 over x2 minus x1, right? We can label the points. The first point is going to be x1 comma y1. The second point is x2, the second coordinate, y2. So this subtraction will be easy because Layla started at 0, so it's going to be 50 minus 0 over 8.7 minus 0, so that's 50 divided by 8.7, and that's going to equal, we actually have done that calculation here, 5.7 meters per second. That's the slope, is 5.7. The slope-intercept form of the line, remember, is y equals mx plus b. So it's going to be y equals, we found the slope, 5.7 x, and then b is the y-intercept. Layla's y-intercept was 0 since she started at the start. So that is the equation of her line. And if we use d and t for distance and time, y is distance, so d equals 5.7x. Or we could use function notation. We could say f of x equals 5.7x. So those are all different ways we could write that. So you'll do that. You'll do this page, page 2, and then you'll do the graph and answer these questions. In the school year 22-23, we ran out of time, and we'll do this together in class, the next class.